In this session, I'll be going to explain one example of root locus. So one can easily see here transfer function for a system is given by k divided by s plus 2, and that is been there with unity feedback. So let us solve example for this root locus. So let us begin it with first step. So step number 1, that is to obtain Loci. Here number of poles in this example, that is 2. So number of poles, that is 2, and number of zeros, that is 0. Now let us calculate total number of asymptotes. So next step, that is number of asymptotes. So number of asymptotes, that is total number of poles minus total number of zeros. Over here total number of poles are 2 and total number of zeros are 0. So this is 2. Next step is angle of asymptotes. So step number 3 for this example, that is angle of asymptotes. So here angle of asymptotes, that is theta is equals to 2x plus 1 divided by pole minus 0 into 180, where x value, that is 0 and 1. The reason is number of asymptotes are 2. So if I place x is equals to 0 inside, so this will be 1 into 180 divided by 2. So that will be 90. And if I place x is equals to 1, then this will be 2 plus 1, 3 into 180 divided by 2. So that will be 270. So angles of asymptote, that is 90 and 270. Now next step over here, that is to have a calculation of centroid of asymptotes. So step number 4, that is to have a calculation of centroid of asymptotes. So over here for this centroid of asymptotes is summation of real part of pole minus summation of real part of zeros divided by poles minus 0. So here we have poles, first pole that is there at 0 and second pole that is there at minus 2, and there is no 0. So summation of real parts of poles, that is 0 plus minus 2. So this is minus 2, and summation of real part of zeros, so that is 0 divided by poles minus 0, that is 2. So this will be minus 1. So centroid of asymptote, that is minus 1. Now next step is to have a calculation of breakaway point. So next step, that is break away point. Now for breakaway point, we need to obtain characteristic equation first. So characteristic equation, so that is 1 plus gs hs is equals to 0. Now 1 plus gs is, in this case it is k divided by s into s plus 2, and hs is 1. So based on this, you can say characteristic equation is s square plus 2s plus k is equals to 0. So now I will be calculating k is equals to minus s square minus 2s. Now next step is calculate dk by ds is equals to 0. So dk by ds over here, that is minus into s square's differentiation is 2s minus 2 into s differentiation is 1, and if it is equals to 0, we can say s is equals to minus 1. So we have breakaway point, that is at s is equals to minus 1. Now next step in this example is to have a calculation of intersection to imaginary axis. So step 6, that is intersection to imaginary axis. So here first we need to write down characteristic equation, and that is 1 plus gs hs is equals to 0. In last session we have derived this, so let us directly write it. So s square plus 2s plus k is equals to 0. Now second step is to construct Routh array. So Routh array based on this equation. So that is s square s to the power 1 s to the power 0. S to the power 2, that is having one coefficient, skip 1, and that is having k, and s to the power having 2 coefficient and skip, there is nothing, so over here it will be 0. So next coefficient, that is this, which will be 2 into k minus 1 into 0 divided by 2, so that will be k. So here for a stability, we have value of k that should be greater than 0, and there is no intersection to imaginary point. The reason is there is no marginal cable, no k marginally stable system. So we don't have any intersection to imaginary axis. Now after having all those steps, let us have a plotting of root locus. So let us have a plot of root locus. So in this system we were been having two poles. So let us place those two poles. One pole is at s is equals to 0 and one pole is at s is equals to minus 2. So here we have two pole. One is at s is equals to 0, and over here one another pole is there, that is at s is equals to minus 2, and there is no 0. And in this example we are being having two asymptotes. One asymptote is having angle 90 and second asymptote is having angle 270, and centroid of asymptote, that is at minus 1. So over here we have centroid of asymptote. So centroid of asymptote sigma c, that was there at minus 1, and angle of asymptote, that was there at theta is equals to 90 and at theta is equals to 270. So this is what we have computed, and then we have seen breakaway point. So breakaway point, that was there at minus 1. So even I'll have to say as break, I'm writing it for breakaway point, that is at s is equals to minus 1. So centroid is at minus 1, breakaway point is at minus 1, and angle of asymptotes are there at 90 degree and 270 degree, which we can say it over here. Now, how to begin with example for plotting of this after calculating all those data. So remember, always line of root locus that will always emerges from poles, and that will try to enclose to zeros, and if number of zeros are less, in that case that will go to infinite. So line that will begin from both of these poles, and that will go to breakaway point. And one more thing that we need to remember, from one pole one line will emerge. So from one pole two line cannot emerge. From one pole only one line can emerge. So from here only one line will emerge, and basic first rule of root locus is root locus plot should be always symmetric with respect to real axis. So definitely from here whatever line is getting emerged, that will go in this direction, and the line which is emerging from this, that will go in this direction, and that will get breakaway at this point. And after getting breakaway, now it will be moving towards asymptotes. So see, that is how it is moving towards asymptote. So ultimately over here at pole k is equals to 0, and as it moves towards infinite, there will be k is equals to infinite. There will be k is equals to infinite. So that is how it is getting moved. So this is what the consideration which we need to see when we solve the root locus example. In next session, few more difficult examples for root locus that we'll be going to see. So let us see those examples based on root locus in next session. Thank you so much for watching this video.